All right. So hi everyone. Today we're going to continue our look into the SBP paper 2. Okay, and oh dear. So this SBP paper 2, yesterday we saw section A. So today we're going to be looking at section B and section C. Okay. It's already 2021 and I'm still writing 2020. Anyway. Okay, so diagram 9.1, 9.2 show two identical boat paddles partially immersed in the lake water and sea water. Biggest difference between lake and sea water is what? Anybody?
Density.
Satu less than satu, yeah.
Ya, mana satu yang less dense?
Lake.
Like, yeah.
Really? Are you sure?
Seawater.
Seawater is less dense. Jeremy said lake water is less dense.
Lake.
Sea water dia more dense.
Yes.
Sebab?
Ada garam.
Dia ada garam.
Sebab ada garam. Okay, fine. So yeah, so lake water is actually less dense lah. We assume that lake water is fresh water. So fresh water is like pure water. Okay, although actually it's not true lah. Okay, lake water actually is not pure water, but we assume that there is less stuff in the lake than in the sea. Tapi apapun kita tengok dulu dia punya ini. So look at the refractive index. There's a very minor difference. Okay, but obviously because the refractive index of seawater is bigger, so we have to assume that the density is bigger lah over here. This one, the density is lower. Okay, even the speed light, okay, oh, that's interesting. Hold on, the refractive index is smaller in the lake water than in the sea water, but the speed of light is faster. Yeah lah, so the density of the lake water is lower than the sea water. Okay lah. Bah, so first question as always, choose the correct answer. This is so interesting. Jarang dia akan buat choose the correct answer kan in essay, because usually you have to like gariskan or you have to bulatkan makan. So what happens if you are approached with this question in section B dan kamu tahu yang kamu kena jawab inside a piece of paper or inside kamu punya buku jawapan. Okay, what you do is you copy the whole sentence again. Okay, but only write the correct answer. Okay, so you copy the whole sentence again, you only write the correct answer and underline that correct answer. Okay, do you get what I mean? Because it's a section B question. Okay, usually kan soalan yang jenis begini kan dia keluar di section A, terus kau bulatkan atau kamu gariskan di sana lah. But because this is section B, it is pretty interesting lah. Jarang saya jumpa section B kan yang dia suruh kamu pilih jawapan. Okay, so if this happens, make sure to write the full sentence and underline the correct. No, you write the correct answer and you underline it, so that it's very obvious that that is the word that you're choosing. Okay, so phenomenon happens because of the change in velocity or frequency. Okay, change in velocity of the light. Okay, obviously we know that this phenomenon is, what phenomenon is this?
Refraction.
Berkaitan dengan refractive index, so this will be refraction.
Yes.
Okay, just to recap, refraction is the bending of light. Okay, bending of light apabila dia melalui two different mediums. Okay, so don't forget the full definition of it. I'm just giving you the first three words lah. Okay, refraction is the bending of light. Okay, because of different mediums or change of speed or velocity. Okay, all right. So based on 9.1, 9.2, compare the refractive index, please. Anybody?
9.1 smaller than 9.2.
Okay, 9.1 smaller than 9.2. The bending of the paddle. Okay. Sorry. Anybody?
Sama juga.
Sama juga.
Sama juga. Okay, 9.1 is smaller than 9.2. The speed of light.
Terbalik.
Terbalik. 9.1 is bigger than 9.2 or 9.2 is smaller than 9.1 lah. Okay, whichever one. All right, relate the speed of light and the refractive index. This one first.
Bigger refractive index
Smaller
Refractive.
speed
Yes.
of light.
Okay, bigger refractive index, smaller speed of light. Is that
Yeah.
what you're saying? Atau terbalik?
Ngam sir.
Saya rasa begitulah.
Okay, so the bigger the refractive index, okay, the smaller the speed of light. Okay, because the refractive index will affect the speed of light. Okay, refractive index yang tidak berubah. So itu yang mesti duluan datang. That one must come first lah. Okay, so the bigger the refractive index, the smaller the speed of light. Notice that the question gives speed of light first. Okay, and I've said this many times. Okay, the purpose of them changing the order is to trap people. Okay, is to make sure that when you answer, your brains are turned on. You're not just copying brainlessly. Okay, so please remember this when you're doing relationship. Okay, state the physics concept. This one is quite easy. What's the physics concept involved?
Refraction of light.
Refraction.
Okay, thank you. Refraction of light. Okay, you can, don't need light pun boleh, tapi kalau kamu tulis light lagi bagus lah. Okay, refraction of light. So this is a pretty simple compare and relate question lah. Okay, cuma yang paling penting is remember that when you relate, you need to turn on your brains. Okay, hold on. Let me just check something. I think I need to. All right. Diagram 9.3 shows a turtle in the empty aquarium. Diagram 9.4 shows the aquarium filled with water, which causes the image of the turtle to be bigger. Okay, this is a very standard one. So this one, no water, poor turtle, no water, cannot swim. Then in 9.4, there will be water. Okay, so the water acts as a lens. So what we're doing is we are explaining the situation, but we also have to show a ray diagram. Okay, so first of all, tell me what situation is this first. I know it's refraction, tapi this is a very specific one. Ada yang satu tiada air dan ada yang satu yang ada air. What situation are we talking about here? Anybody?
Real depth, apparent depth, maybe.
Okay, so this is real depth and apparent depth. Okay, so in the real depth and apparent depth situation, if you remember this one lah, okay, so you start with the water surface. Okay, then you start with, you don't have to draw the turtle if you don't want to. Okay, but you can always draw a coin or something lah. Okay, you can always draw a coin, and then, okay, so this is the surface of the water. Okay, ini adalah the surface of the water. So this is the real depth. Okay, and we know that the object becomes bigger because of the apparent depth. Dia kelihatan lebih dekat kepada kita. So the apparent depth, the object will look something like this. Okay, so since this is the eye, this is my second attempt at drawing this. So okay, so from the eye to the apparent depth, okay, to the apparent image. So this is the apparent depth. Okay, so from the eye to the apparent depth, okay, we draw a straight line over here, like that. Okay, so that's the one that we see lah. Okay, because our eye can only see light in a straight direction. Okay, but over where the sempadan is, you draw the normal line. Okay, I should have drawn this bigger again. Okay, but anyway. So over here, then you draw this one. Okay, just to show that it is moving away from normal. Do I need to draw this for the third time? Maybe I should make the eye bigger lah. Okay, anyway, it is going from more dense, okay, to less dense. So this green line, actually, this green line is supposed to go away from the normal. The refractive angle is bigger than the incident angle. Okay, so sepatutnya dia pergi lebih jauh lah, menjauhi normal. But because our eye can only see in a straight direction, So bila kita panjangkan ini ke belakang with dotted lines, we will see the image over here. Okay, should I draw a much bigger one? Okay, so the explanation is a pretty standard one. So the first one will be talk about the light from the turtle to the air. Okay, so light travels from the turtle to the air. Okay, otherwise known as high density to lower density. Okay, that's the first mark. Okay, so you travel from, I mean, it is basically a refraction explanation. All refraction explanation can you always talk about where light goes to. Okay, so then the second mark is bila dia jalan daripada high density to low density, what happens? Okay, refraction occurs and the light bends in which direction?
Away from
Very
normal.
standard. Okay, away from normal. Okay, to the eye. Ini jalan yang mungkin berlainan sikit lah, to the eye, because we're specifically talking about real depth, apparent depth. So refraction occurs and the light bends away from normal. Any refraction question will always have this same explanation one. First kamu cakap light pergi dari mana ke mana, high density, low density, high density. And secondly, you talk about refraction happens and then itu light itu sama ada dia bend away from normal or nearer to normal. Okay, all refraction questions explanations always talk about the same thing. Okay, cuma in real depth, apparent depth okay, so the third one so light travels in a straight line. Light travels in a straight line. Okay, and then n causes the image to appear. Nearer lah, okay, nearer to the eye. Begitu. Yang kita nampak bahkan cahaya yang sampai kepada kita is the refracted light, but we see it straight because our eyes cannot understand refraction. Okay, we only see light in a straight line. So when light comes to us, we see, oh, okay, the thing looks nearer than this one. So 3 marks for the explanation and 1 mark for this diagram. Okay, 3 markah untuk explanation, 1 mark for this diagram. So the first two for me, I think is the most important lah. Whenever you are faced with any refraction question, talk about these two first. Okay, pergi dari mana ke mana, and then sama ada dia bending away from the normal or towards the normal. Okay, that is a very safe kind of answer lah. Okay, must draw diagram is the question. Yes, must draw diagram because it is already stated in the question. If there is no statement in the question, then you don't have to draw a diagram. But because they ask you to draw with a ray diagram, so you have to. Okay, so yeah, the ray diagram actually helps to understand a lot more. Of course, my diagram is very ugly. Okay, I should draw it much bigger. Maybe I should draw the eye like this big, and then senang kita mau nampak. Okay, then it's very easy to see. Okay, travel from here to here. Oh well, anyway. Okay, diagram 9.4 shows a crack on an internal wall on the surface of a car engine. So when I first saw this question, I thought, very strange, how come light question, then suddenly talk about car engine? Because car engine we always see in chapter 2, forces and motion, kan? Tapi tiba-tiba they talk about light. Okay, but anyway, the crack cannot be seen from the outside, so suggests a design of a device that can be inserted into the car engine. Okay, by using the device, the mechanic can see the internal wall surface of the car engine in order to detect the fault areas such as crack or dust rust without the need to dismantle the engine components. Okay, so we have to talk about the modifications based on these aspects: type of cable, the characteristics, and additional features, okay, that we use to display clear image and maneuverable in the coil space of the coil. Okay, so it's a very loaded question lah. Actually, if you think about it, all you have to do is replace the car engine with your kidney, kamu punya hati atau kamu punya ginjal. Okay, that's basically what the question is asking. If let's say you just take away the engine and you say that, oh, okay, I want to check my kidney. Okay, what do we use? Okay, so actually oh no, I got no space to write answer. Alamak. Okay, so the type of cable, okay, is obviously a fiber optic lah. Okay, that one is definite because this question is exactly the same as kalau kamu ada kecederaan di dalam badan, but you don't want to make a cut, you just want to check di dalam. So we use fiber optic. Okay, we use a fiber optic cable lah. Okay, in this one. So the reason why we use fiber optic cable, I'm going to write the reason in green. Okay, so that total internal reflection. Okay, thank you. Can occur. Okay, so we use fiber optics now for total internal reflection. That's why I say this is a very interesting question lah. Dia basically ambil soalan yang berkaitan dengan kesihatan, which we are very used to. Okay, kita sangat lazim melihat questions that have to do with, want to check the hati lah, want to check the kidney lah, want to check the heart lah, whatever, want to check the appendix ke apa kan. But now they change the situation and put it into the engine. But actually it's asking the same thing. Okay, they just change the situation and then they put a lot of funky words over here just to throw you off. Okay, but when you dismantle everything kan, rupa-rupanya is not that this one lah. Okay, not that difficult. Okay, let's talk about the characteristics. What should the characteristics of good fiber optic cables be? Anybody want to try? Okay, Jeremy says flexible. Okay, it can be flexible. Flexible is an answer for reason. What makes it flexible?
Easily bend.
Okay. Oh yeah, sorry. Okay, yeah. Flexible. No, elastic is not so suitable. Okay, flexible. Then you can say it will be. Oh, sorry, green. Easily bend lah. Okay, easily bend, senang untuk dibengkokkan. Yeah, okay, to follow the shape, okay, of the, is it coil? Yeah, coil, kan sini. Coil space of the car engine. Okay, in shape of the coil space. Okay, so one characteristic is flexible. Okay, what else? If you want to see the whole engine, okay, you not just only need a fiber optic that is flexible, you also need a fiber optic that is... Any suggestion?
Big.
Long.
Okay, long is a better word. Big not so suitable. Okay, nanti saya cakap pasal big. Okay, so why should the cable be long?
So that it can reach further.
Sorry, one at a time, please. So that it can... Oh, sorry. So that it can... Terus when I say one at a time, kan?
Travel further.
Okay, so that it can travel further. Okay lah, you can also say that. So that it can travel further into the engine. Okay, atau yang sewaktu dengannya lah, so that you can see more parts of the engine. Kamu boleh nampak lebih banyak bahagian dalam engine tersebut. Okay, so that is another reason. Okay, 3. We need another 2 more, I think. Yeah, because it's just one type and then 4 characteristics. Oh, additional features. Okay. Never mind. Anything else? Either characteristics or additional features. So, kalau kau selalu tengok fiber optic ni kan, kau akan tahu.
Jeremy cakap tin.
Thin. Okay. Obviously, you want a thin wire. Thin wire usually is associated with small diameter lah. Okay, thin wire, small diameter. Kalau kamu mau cakap cross sectional area small also boleh. Okay, why? Why thin or small diameter?
So that it can reach to smaller part.
Okay, so that it can reach to smaller part. So that it can reach to smaller spaces. Okay, ruang yang lebih kecil lah. Okay, so that it can reach to smaller spaces. Now I regret not putting a jadual sedia. Okay, one last one. Additional features lah. We have talked about characteristic. We haven't talked about additional features. What should there be? Apa yang kita harus tambah pada fiber optic cable kita so that we can see better? This one usually is a pretty standard answer actually. Even in the black book should have. Cuma dia bukan pasal engine lah, dia pasal badan manusia. Anyone? Magnifying glass, objective lens and eyepiece. I think objective lens and eyepiece is a little bit too much of a stretch lah, but magnifying glass. Magnifying glass, objective lens and eyepiece. Fiber optic cables are usually too small to put a magnifying glass lah, I feel, or to put even a lens, because kamu bukan menengok daripada you don't see the end of the cable. So if you want to have an objective lens and an eyepiece kan, you need to put your eye at the cable. But usually we don't put eye at the cable lah. You know, if this is the cable kan, cable is actually thinner than my earphone, you know. So you don't put this because you're not, you know, you kind of have to kind of project it to a screen or to a computer lah, then you can see our video. Okay, so usually at the end of the fiber optic, okay, di penghujung satu fiber optic itu kan, okay, there is usually a video camera lah. Okay, there's usually a video camera because you need to be able to see the inside. Okay, so okay, so I think Ethan has gotten a good answer. Okay, so you put an LED light, okay, or a lamp lah. You can put a lamp that is high power lah. Okay, into the end of this one. Okay, you can also put a camera if you want a camera. Tong or whoever just now said you can put a 4K camera also if you want. Boleh lah. Okay, if you really want to check the engine in 4K, then you can put a 4K camera lah. Okay, but the purpose of this, the putting the light, the lamp, and the 4K camera is so that the image, okay, can be easily seen. Okay, or you can also say the image is brighter, lebih terang. Okay, you can see the image easily because you have a camera at the end. A 4K camera will also be very good, okay, because you can see all the defects of your engine in 4K. Okay, semua tagar, semua rust over there you can see lah. Okay, very good. But this is essentially kind of the same thing lah. Okay, so let's say if this question comes out in SPM and you want to put LED light as one, you want to put 4K camera as one, go ahead. Okay, as I said before, I highly suggest that you give more than 5 suggestions. Okay, and be as creative as you can, because sometimes the creativity is what they are looking for. Okay, although there's a set answer over there, but sometimes, you know, when you're creative, you never know. Okay, mana tahu jawapan kamu akan diterima. Okay, are we done with this? Yes, I think we're done with this. Okay, number 10. Number 10 is This is logic gate. Okay, logic gate question. Okay, table 10.1 and 10.2 are the two truth tables that show the operation of the electric circuit. Okay, what do you think this is? Well, okay, let's see. So what is a logic gate? This one I've given already, right? Anybody? Saya sudah beri ni sebelum ni.
Many output, one input.
Need one output.
An electric component with a single output and one or more input.
Yeah, I heard many output, one input. Tidak, it's many input, one output. Okay,
Salah-salah.
be very careful. And electronic component. Electronic component. Okay, that has many inputs. Okay, and only one output. This is a standard one. Okay, I think I found the reason already. So, apparently this thing, kenapa? Okay, so apparently this thing is arranged in parallel to the bulb. Manakala, kalau dia adalah OR, if it is the OR gate, like if it's the real OR gate lah, the real OR gate will be like this. The switch, and the switch. Okay, and then it is actually arranged. So the switches are arranged in series to the bulb. This is OR. Okay, but this one is, this is the arrangement for a NOR gate because the switches are arranged in parallel to the bulb. Wow, okay. I did not even think about this. This is so strange.
Spot SPM.
Yeah. Okay, so this is a NOR gate actually. Dia punya arrangement of this lah. Yeah. So if it is a NAND gate, it's the same exact thing. You have the battery. Okay, you have the resistor over here, but the two switches are arranged in series. Okay, but in parallel to the mentor. Ini adalah NAND. Kalau N, okay, it is like this. Okay, the resistor, but there's only one circuit. Like this. There is no dua jalan bah. This is the AND gate. This is the NAND gate. This is the AND gate. So the two switches are next to the metal. But for the NAND or the NOR gate, the two switches are opposite the mentor. The two switches are opposite the mentor, the bulb. Wow, I was 2 years old. Padahal saya sudah ajar ni banyak kali, baru hari ini saya ingat balik. Yeah, so because of that, the 0 and 1 will give you 0. 1 and 1 will give you 1, and 0 and 0 will give you 0. Because NOR gate is tambah and then, sorry, 0 and 1. Sorry. 0, 0 and 1, correct. Sebab NOR gate is dia tambah lepas tu dia kasih terbalik. So 1 plus 0 is 1, but you will get 0. Okay. Yeah. So there's a question here. Why can't the current just travel from the battery resistor bulb to battery? That's what I also thought. Battery resistor bulb to this one. Yeah, that's what I also thought. Hold on now. Output resistor is obtained when switch A and switch B is on. Oh, okay. Okay. How are we going to finish at 12:30? Sorry, let me bump this. Okay, so the idea is this. So current will flow through here, okay, and then it will come through here lah. Okay, sorry, this is like boring you then don't need lah. But if both of this is off, okay, if both of this is off, then the current has no choice but to flow through here. No choice. Sebab this way sudah kena block. Okay, so definitely the mantle will come on lah. So when A is off and B is off, then you will get the mantle menyala. Okay. Now, if it is this one on, if this one is on and this one is off, so we're talking about this case. Okay. So what happens now to the current? Since there is an easier way to jalan over here, okay, the current will flow through this direction. Okay, because remember, current is like every other teenager in this world. They always like to find the fastest way out. Okay, the path with the least resistance. Okay, so if you give the current a choice, he wouldn't want to go through here. It must come through here. Sebab dia mau ambil jalan yang paling pintas. Why would it take one whole round, terpaksa melalui the mental and then come back here? No need to do this lah. Okay, so because of that, this will be, the bulb will be 0 because there's no current flowing through the bulb because the current just taking the path of the path of the A switch. Okay, and so because of that, if we follow this, if this is 0, if this is off and this is on, it's the same situation as the first one. This will still be 0. Okay, because current comes over here and this. Okay, it will not, tidak akan teragak pun, it wouldn't bother to go through the menthol. Because for what? Okay, there's a lot of resistance there. Saya pakai jalan yang paling pintas lah, the easiest road. Okay, so you get this. But if this is 1 and this is 1, this is probably the point of contention, right? Yeah. If this is 1, this is also 0 lah. Because now the current has, bukan lagi dua jalan, bukan lagi satu jalan yang tiada resistance, dua jalan pun tiada resistance. Okay, so the only way for the current to flow through the bulb is if you turn both of these off. When you turn both of these off, the current has no choice. It has to flow through the bulb. So over here, the bulb will be on. Wow, this is so interesting. Yeah, anyway, I was 2 years old. So anyway, JKL also will follow the same premise now. It will also be 0, 0, 1. Okay, because this is basically a no, this is a NOR gate. Yeah, this is a NOR gate. Because 1 plus 0 is 1, but not bahkan, so it'll be 0. Yeah. Okay. Okay, anyway, we are not, oh gosh, I feel so sad. But never mind. Okay, something that we can learn now. Okay, if you don't understand this, you can always watch the YouTube video again after Chinese New Year lah. Okay, lama lagi physics kan? 1 March. Yeah, it's 1st of March. So lama lagi. Okay, we can think about this after your sejarah paper. So anyway, what is the logic gate is already done. State the output. Okay, so it'll be 0, 0, 1 and 0, 0, 1 for both lah. Okay, because both of them, so the condition of the inputs and the condition of the outputs. So the answer will be when both inputs are off. Okay, the output will be on. Okay, 1 mark only lah. When both inputs are off, then the output will be on. This is a very special kind of compare question. So ini jarang yang kita nampak ni compare question begini. Okay, but it's good for us to revise on this lah. Okay, stop annotating on my screen, whoever is doing this. What? Thank you. Okay. So based on your answer in 10B, state the logic gate that represents the output of both. So this will be the NOR gate lah. Okay. So I guess at this stage, let's say if this is the real SPM lah, and you are berdepan dengan soalan ini dan soalan ini, the light question lah. It seems that the light question is an easier question lah. Okay, although ramai orang yang cakap, oh saya tidak suka light because light is difficult. Not sure though. Actually now at this point I don't know why I like anymore lah. Okay, so yeah, NOR gate. Just to remind you, the NAND gate, Okay, in case it comes out, the NAND gate, dia punya susunan adalah begini, the mantle is over here, but it will be two switches in series. Okay, so for the NAND gate to happen, both switches must be on. Okay, A and B, and then this is the mantle. So if both switches are off, it will be off. No, both switches are off, it will be on. Okay, if one switch is on, it will still be on. One switch will still be on. Both switches on, then it will be off. Okay, this is the NAND arrangement. Okay, and the NAND arrangement is huruf D and a dot over here. Okay, the NOR gate is a huruf A and a dot. Two inputs and one output. Okay, so the NAND gate works along the same principle. As long as there is a path where the current can flow that has less resistance, it will follow that path. But the only way the current can flow through here is if A and B are on. Dua-dua A, B on, baru dia boleh melalui sini dan C tidak akan menyala. C will be off because the current doesn't flow through the metal, the bulb. Okay. In reality, okay, sorry, this is if you are interested to listen. If you're not interested to listen, you can take a drink of water. In reality, C, all these things kan yang kita cakap 0, 0, 0 ini kan, sebenarnya dia bukan totally off lah. There's just less current. Dia menyala tetapi sangat malap. Okay, that's the reality of the situation. But for us, we are very binary lah. We only know on and off. Okay, so to us, off means totally don't have and on means totally ada lah. Okay, but in reality, there is some current lah flowing through here. Okay, there's always going to be some, but very, very little. But that's the reality lah. Okay, so anyway, okay. Let's come back to this. Lina uses a logic gate control system to switch on an air conditioner in her room. Okay, the system uses the logic gate N, okay, to switch on the air conditioner when she is in her room di dalam bilik on a hot day. Okay, so diagram shows this. Switch X is a thermistor that changes its resistance due to changes in temperature. Can anybody tell me thermistor how? High resistance on or off? When is the situation with high resistance? When is the situation with low resistance? When it is hot or when it is cold? Anyone?
On.
Low.
Hot on. Hot on. Okay, high resistance is cold, low resistance.
High low.
High low. What is high low?
Low
High
resistance dia. Yeah.
Temperature, low resistance.
Okay, when the low resistance, it will be hot. High temperature, low resistance. Low temperature, high resistance. Yes, okay. So, based on the circuit diagram, what will the air conditioner be activated when Lina is in her room during the hot day? Based on this, will it be on or will it be off? Where is the thermistor?
XY itu sir. Switch.
Oh, sorry. X is the thermistor. Okay. So when it is a hot day, it will be low resistance. Low resistance means 1 or 0.
1.
1.
1. Okay, low resistance means 1. And then Y will be if there's, so if 1, 1, so this will be 1 lah, because AND gate. Okay, so this will be on. Okay, but so just to remind you, for thermistor, okay, high resistance means cold, cold means it will be off. Okay, low resistance means hot, hot will be on. Okay, for thermistor lah. Huh? You mean this long question just for 1 mark? Oh, okay, fine. Explain your answer. Oh, patutlah. Oh ya kan? Baru ni. Okay, so explain the answer, please. This is very easy though.
When hot,
Anybody?
High.
low resistance.
During a hot day, the resistance of the thermistor decreases.
Okay, during hot day, resistance of thermistor decreases. Okay. Sambung lah kalau.
When Lina is in the room,
Okay.
infrared.
When Lina is in the room, the infrared sensor will turn on. Okay. But wait, this is actually kind of like the third point already. You are missing one point here. So what if during a hot day, the resistance of the thermistor decreases? Oh, this is a 3-mark question, sorry. So this is only the second mark. Ini belum lengkap ini. During a hot day, the resistance of the thermistor decreases. So?
Current flow.
So voltage is high.
Actually, you can totally skip. Okay, notice that the second point, when Lina is in the room, the infrared sensor will turn on. That is the condition yang menyebabkan the infrared sensor to turn on. We know that the thermistor must turn on. So itu lagi yang kamu belum cakap sebenarnya. During the hot day, the resistance of the thermistor decreases. So switch X
Is on.
okay, will turn on. So kamu kena jelaskan why the switch X will turn on and then why the infrared sensor will turn on. Okay, so that's the this one lah. Okay, and then of course the third and the final mark will be the output is on. Okay, the output is on and the relay switch will turn on the AC. The secondary circuit lah. Okay. So 3 marks, one to explain why X will on, one to explain why sensor Y will on, and then the third mark is what is the output and how does that affect the relay switch. Question number 10, we pause for a while, okay, sorry, because I really want to finish this today, okay. Question number 11, sorry everyone. Those of you who came and you're like expecting this miraculous answer, sorry. Okay, fighter jet taking off into the air. Okay,
Yes.
aerofoil shape. Aerofoil shape is just basically like this. Okay, asalkan satu di atas adalah melengkung dan di bawah adalah lurus lah. Okay, you can draw it a little bit sharper if you want at the back. Okay. Di kampung-kampung kan kami panggil ini barangkas. Balangkas kayak itu. Okay. Yeah, anyway. So slightly like that lah. This is a very extra lah. Okay, asalkan di atas is curve and bottom is this one. Okay, so using the Bernoulli principle, explain how the jet can fly. This is a 4-mark question. So very easy now. 2 marks for upstairs, 1 mark for 1 mark for upstairs, 1 mark for downstairs, and then what causes it to go up. Anyone want to try?
Jeremy tulis jawapan penuh sudah sir di chat.
The velocity of the air at the top of the wing is higher than the velocity of the air at the lower side of the wing. 1 mark. This creates a lower pressure region at the top of the aerofoil of the wing. 2nd mark. This creates a difference in pressure which produces a lift force. 3rd mark. Hold on, higher force move with higher speed. Okay. Yalah, jawapan Jeremy boleh lah tu. Everybody, if you want to answer, read Jeremy's answer. Actually, the answer over here is even more weird than before. But actually, yeah, Jeremy's answer is pretty, this one, there's pretty standard Bernoulli principle answer lah. Okay, velocity on above the wing,
High.
okay, is high. Okay, so pressure
Low.
is low. Then secondly, velocity under the wing, di bawah sini, okay, under the wing is low. You can also edit by say velocity of the wind lah. Okay, kalau kamu mau cakap, but you don't have to say lah. The velocity of the wind under the wing is low, therefore pressure is high. And then the very standard answer is the difference in pressure, okay, creates a lift force. Okay, standard Bernoulli's principle answer. Atas tinggi, bawah rendah, so pressure above is low, pressure down is high. So low pressure, high pressure, so you cause a lift force. Okay, force will always go from high pressure to low pressure region. Okay, sorry, can I continue? Okay, don't worry, you can always take a screenshot. All right, fighter jet F-35 has a single engine. The forward thrust produced by the engine is 200,000 newtons. The mass of the jet, including the engine, is 13,300 kg. So count the greatest acceleration. This will be F equals to ma. Okay, did anybody do this? Can you tell me what's the answer for A? F is 20,000, M is 13,300 kg. 13,300 kg.
16.04.
Okay, 16.16.
15.
15
Okay,
point pasang
15.04 meters per second squared. Okay, so the jet must reach 285 kilometers per hour to achieve takeoff. Okay, but you want to calculate the minimum length of runway, bahkan. So this is a pretty standard question. You need to use V squared equals to U squared plus 2AS. Okay, S yang kamu mau kira. Cuma 285 kan tak boleh pakai ya, because it's in kilometers per hour. So do you remember I gave you the kind of petua to change from kilometers to hour to meters per second squared? It's not even a petua anymore. It's just a shortcut now. You can call it a life hack if you want. Kilometers per hour to meter per second squared. What do we times what? Divide by what? Saya lupa sudah, what's the number? It's a very strange number.
15/8 kah? Apa?
Is it 15/8?
Nggak tahu sir.
I think if you check one of your SPP, no, if you check one of your, if you check one of your kertas trial kan, ada itu saya tertulis di sana, somewhere lah. Hold on. So
5/18 sir. 5/18.
5/18.
darab kah?
Ya macam
Yes.
Ya macam kan? No, divide kah? 285 times 5/18. Yeah, okay. Times 5/18. This is divide by 5/18. Okay. How did I get 5/18 kan? Today is not the day to talk about it. I mean, we have no time lah. Okay, so just remember the magic numbers lah. Okay, maybe before paper 1 kan on physics, the real day kan, ingat na, kilometer per hour tukar pergi meters per second, darab 5/18 saja. Jangan tanya kenapa. Okay, hafal je. Nanti kalau mau tanya kenapa lepas SPM baru kamu explore lah. Okay, so you will get the answer S equals to 208.5. Okay, meters. Please remember that most calculation questions that involve speed, okay, most of the time they will give you 1 in kilometer per hour, but you have to change it to meters per second squared because we're not talking kilometers. Okay, we're talking about meters. So meters per second squared. Be very careful with this. U is 0 lah. Because kalau dia mau take off kan, dia mesti bermula dari kosong. Then it starts moving. So U is 0. V is this one lah. Lepas kamu tukar 285 to become berapa kira tu? 79.17. Okay, that's V. Lepas kamu tukar, okay, after you change 285 kilometers per hour, darab 5/18, you get 79.17 meters per second squared. Meters per second. Okay, so this is the final answer. Please check this lah. Okay, Azizul Hasni Awang, during a competition in World Track, you are required to determine the most suitable track bike. Okay, so the best bike for him. Okay, let's talk about this frame. What kind of frame should it be?
Carbon fiber.
Carbon fiber.
Carbon fiber.
Okay, why carbon fiber?
Light.
Ringan. Light.
Okay, so it is light. It's not just light, it is also strong. But actually alloy steel is also strong. Okay, but can lah, boleh lah. Okay, shape of the bicycle, aerofoil or aerodynamic?
Aerodynamic.
Dynamic.
Oh no. Shape of the bicycle should be aerofoil. Sorry, guys.
Aero?
Yeah. Shape of the bicycle should be aerofoil. The way you bend your body makes it aerodynamic. Okay. Yeah. Actually, you know what you should do? You should take a video of yourself. Okay. Like a reaction video lah. Then you Google what's the difference between aerodynamic and aerofoil. And then you take the video of your reaction. Then you send it to me. Wow, sir, I was 2 years old. Begitu. Okay, there is a difference between aerofoil and aerodynamic. Okay, but the good news is, no matter what you choose, the reason is still the same lah. Okay, is to reduce air friction.
So bila mau guna air friction sama air resistance.
Air resistance.
Sorry, air resistance.
Resistance.
Sorry. Air resistance.
Yes, sir.
Yes.
Okay, mass of bicycle.
Big.
Smaller mass.
Smaller
Lighter.
mass lah. Why smaller mass? Because it apa ini? Okay, because it is lighter. Okay, tire tread. Corak bunga pada tayar. Narrow with tread or narrow without tread?
Narrow without thread.
With
No
thread.
thread.
Without
Okay,
thread.
kenapa without tread?
Reduce friction of
Friction.
Yeah, friction.
Okay,
Friction.
so we want to decrease friction. Okay, kalau tread pattern, if your bicycle has a tread pattern, is not good for the velodrome lah. Okay, tempat di mana pelumba basikal kan, it's called a velodrome, the one that goes round and round and round and round and round kan. We don't want this bunga because we want as little friction as possible. So friction is good if you're going mountain biking. That is good lah. Nobody brings a race bicycle to the mountains, and nobody races a mountain bike in a velodrome. Okay, because the two tires are totally different. Okay, although saya mesti cakap, a lot of people bila dia nampak perkataan tanpa bunga kan, they will immediately swipe left. Wow, sorry, they immediately swipe away lah. Sebab to them tanpa bunga means dangerous, and we don't want dangerous. But ini tiada kaitan dengan dangerous. Dangerous is not Azizul Hasni's worry, Azizul Hasni's worry is saya mau lebih laju. Yeah. Okay, I don't care if I'm dead or if I'm dying. Yang penting saya menang. Okay, so safety is not the issue here. Tapi saya pernah nampak, I have seen a question similar to this. Tapi dia punya soalan dia ubah, bercakap pasal safety. Dia bukan pasal berlumba basikal lah. Actually dia bercakap pasal mountain biking. So be very careful lah. You need to know the purpose of your choice. If you're choosing to race, then you don't want the bunga. Okay, kalau kamu mau keselamatan lah, mau grip lah, mau cengkaman kan, then you want the bunga. Okay, so be very careful lah. Don't bring your own preconceptions atau kamu punya bias diri okay, ke dalam situasi ini. Okay.
Sir, kalau lomba kereta, sir.
Lumba kereta so tiada bunga. Tapi lumba kereta apalah, mau tengok dulu. Kalau lumba kereta F1 tiada bunga itu. Kalau lumba kereta yang yang masuk hutan itu semua kan, itu memang banyak bunga lah. Kalau extreme trucks, I have never seen an extreme truck yang dia punya tayar tiada bunga lah. Dan dia punya tayar semua kan berketul-ketul macam bidding si Aidan kan. So anyway, okay. So, sorry, is Aidan even here? Sorry. Okay, so the best one is S lah. Okay, the best one is S for all the reasons as stated lah. Okay. Oh, okay, Aidan pula di sini. Okay, sorry. Diagram shows a submarine using ultrasonic waves to detect obstacle. Ultrasonic waves, whenever you're talking about this obstacle, obviously this is a calculation question. Calculation that comes to mind will be D equals to VT. VT over 2. Thank you, Prem. Sounds like Prem. Okay.
Yeah.
So what is meant by ultrasonic waves?
Uh, uh,
Sound waves with frequency over 20 kilohertz.
Okay, sound waves with frequency, okay, over 20 kilohertz. Basically, ultrasonic waves is waves that we cannot hear. Okay, dan kita punya heart adalah 20 kilohertz lah. Okay, dia punya frekuensi sangat tinggi sampai kita tidak boleh dengar. Dia tidak kuat, not necessarily kuat, cuma dia tidak dapat didengari. Okay, explain how a submarine uses ultrasonic waves to determine the distance. I think I've answered this question many times, right? Okay, give me the 4 points, please.
transmitter.
Okay, transmitter.
Send
Send wave.
wave to the
Okay,
obstacle.
transmitter sends waves. Sorry, who is that now? That doesn't sound like Prem.
Prem.
Prem
Si
dan
Prem na to.
Okay, transmitter sounds waves where?
to the obstacle.
Okay, to the obstacle, not to the ground. Okay,
To the-
sebab ni na obstacle. Okay, then after that,
The wave will reflect.
okay, wave reflect,
Reflect back.
reflect back. Let's just up our game to the receiver. Memang ada
Receiver.
satu receiver. So it's a transmitter and there's a receiver. Okay, and then the third point.
Time taken,
Okay,
Divide
time
by two.
taken.
recorded.
Not yet. Okay, time taken is recorded. And then the last one will be the distance
Calculated
is
It's
calculated.
by using the formula.
using formula.
What is the formula? Nyatakan the formula lah. Okay.
VT over
D
2.
equals to VT over 2. Okay, so I've answered this before, I think, in a previous video or somewhere, so I'm not going to waste so much time on this lah. Okay, if you want to take a screenshot, better take it now. 4, 3, 2, 1, 0. Okay, submarine transmits. Okay, this one, I think you can do this. Wavelength is this one, frequency is this one, so you can count the velocity. So the basic formula for velocity is V equals to F lambda. Okay, persamaan gelombang lah, the wave equation. So the wave equation will give us a V of 1560 meters per second. Okay, that's the final answer. Now, submarine, yada yada, reflected wave is detected 5,000 milliseconds later. Okay, obviously the trick over here is to change milliseconds to seconds. Okay, so you have to change it first. So 5,000 milliseconds is how many seconds?
1,005.
100.
5 seconds sahaja bahagi 1000. Okay, yeah. Be careful with this guys. Okay, actually dia 5 seconds bahkan. Kenapa dia tidak tulis 5 seconds pada soalan? Sebab dia mahu menguji kamu. Okay, itulah peperiksaan kan. Peperiksaan adalah satu ujian. Gitu. Jadi, so the answer for D will be 3,900 meters. Saya bagi jawapan saja. Please figure this out on your own lah. Okay,
Yes.
I don't think the calculation is too difficult. All right. Diagram 12.3 shows the process of detecting a crack. Another crack. Oh, how come this question so many cracks? Crack here, crack there. Okay, inside a metal block by using sound through non-destructive testing method. So dia tidak mau pakai fiber optic, dia mau pakai sound. Wow. Okay, characteristic of wave. Oh, this is a given sudah lah. Okay, infrasonic or ultrasonic?
Ultrasonic.
Okay, ultrasonic. Why? Ini selalu why ni yang jadi masalah kan?
High frequency. High penetrating.
High frequency. Okay, you can say high frequency, or high frequency usually comes with high penetrating power.
Power.
Yeah, penetrating power. Dia boleh tembus dengan lebih kuat. Okay, you can also say it is non-destructive. Because infrasonic, so infra comes from the word infrared lah. So and No tong. I don't think the answer because ultra will be accepted. Okay. So anyway, infrasonic, if I'm not mistaken, okay. Infrasonic is sound waves that are hot because infra comes from the word infrared. Okay, so infrasonic is not very good because it's sound waves tapi dia panas. So dia mungkin menyebabkan pemecahan. Okay, so we don't want that lah. That's why I say non-destructive. Okay, sebab ultrasonic is just sound waves, no heat. Okay, speed in metal, high or low?
High.
Okay, speed in metal should be high. The wave speed should be high. Okay, so that so actually quite easy.
Shorter time for to detect.
Shorter time to detect what? The flaw.
Oh.
Or the crack. Okay, kamu mengambil masa yang lebih cepat. Lebih kurang. Kamu mengambil masa yang lebih cepat.
Lebih cepat.
Less time. Okay, less time. Okay, small, lebih kecil. Okay, frequency obviously should be high. We already established this before. Okay, and the frequency should be high so that it can high penetrating power. Okay, the scheme over here says can detect small cracks. Okay, because the frequency is high, etc., etc. All right, transducer, contact or angle beam. Wow, it's so interesting. What is a transducer? I think transducer is this one. This is a transducer. So do we want it to be yang bersentuhan atau angle beam? Do you know what's the difference between angle beam and bersentuhan? Okay, kalau bersentuhan means do you put the transducer kan right on top of the brick lah. Means kalau letak di sini. This is you put it on top lah. Macam doctor and the stethoscope kan. The doctor puts the stethoscope right at your chest. That's bersentuhan lah. Kalau angle beam okay. Kalau angle beam, most likely it will put it at they will angle it at a certain angle, and then they will pancar macam ni. Okay, so I think maybe okay, the best way to think about this would be like the stethoscope lah. If the doctor wants to hear your heartbeat, he's not going to put the stethoscope 10 centimeters from your chest and then listen to it, right? It's going to touch the chest. Okay, so I would say that the best type of transducer would be the contact transducer lah. Okay, then you can also do the same reason. Okay, easily detect cracks. Okay, dia lebih senang sebab dia macam stethoscope lah, like the doctor's stethoscope. Okay, no doctor lah, I think will put the stethoscope far away. Okay, so obviously the best flaw detector is Q for sekian jawapan. Sekian sebab. Okay, end of question paper. Yay, we are done.
Yay.